Your task as a team is to... Ooh, don't lick my envelope. That's pretty irritating. Your task as a team is to make 2 octagons. This will turn on eventually if I could figure out my life. I'm going to show you how they go together so that at least you know. Hey, sorry. Get back out of here. Go get a pink slip. You're the one who's late. Jeez. Grumpy. For once. Okay. Where's this going? Hannah. Woo. Ah, my eyes. Don't do that. What a dummy. I'm so stupid. Sorry. It's on. Now I can't see though, so hopefully. Oh my gosh. That wasn't smart. Okay, hold on. Oh, I have a goal. Never mind. I'll tell you later. Sorry. Bye, Luis. You're putting these together. Is that it? And like, get out of here. Also, maybe like rinse off or something. Go, Luis. No. Skinny mini. Your goal is to make an octagon, which means you will need 8 triangles. Just so you know, the widest, well, I don't know. I guess it's the shortest side. The shortest side is the outside of the octagon, and you are lining up like units. Okay, so 2 yards we know is 6 feet, so those 2 get to go together. You're going to need to be able to use your unit conversions. Okay, so like, yeah, we've been working on this now. It's come up in every single homework assignment, being able to convert feet to yards, and square feet to square yards, and inches to square feet. Okay, so that's your task. You'll be forming 2 octagons, 8-siders. While you do that, please make sure that you have out homework 60 through 66. Ready, set, go. Back into that envelope, 16 pieces into that envelope. No. And now we are going to take 10 minutes to talk through our homework problems. Before you guys get started, I just want to make a comment about some of you who chose to kind of ignore that activity or didn't participate. The unit conversions are going to be probably the single biggest thing that keeps you from getting answers right in this class. Okay? We've seen them every night on the homework. There's been different unit conversions. On your quizzes, you're going to start to see unit conversions popping up. Okay? I gave it to you this way so that we could have some time to talk about it, so that you could help each other out. The alternative would be that I hand you a worksheet of 16 unit conversions and you sit quietly and do it by yourself. And we all can agree that that would be boring. Yeah. Okay? So please make sure that when we are doing these types of things, that you're doing your best to participate. And if you don't know how to do something, that you're asking questions. Okay? Please make sure that you're taking advantage of, and not even advantage, but just doing the stuff we're doing in class. Okay, we might be doing it a little differently than you're used to, but it is no less important. Okay, it's no less important just because we're moving shapes and talking about it. All right, so make sure that you guys are engaging with that stuff. Same thing with your homework right now. Make sure you're asking questions of each other. You're pushing each other to explain your answers better. And if you didn't do your homework, now would be a time to fill it in and try and get some late points at least. Okay. 10 minutes is okay? Please keep those conversations focused around math. Ready, set, go. Okay. There we go. So let's talk real quick about answers. Now's not the time for you to be talking. This is it. 60, 342, $342. What? Here's 61, these the 3 areas. For 62, all the areas of those different houses. What is the surface area? I can't looking at 63. Well, I'll come back. 63, 5600. Matthew, Dominic. 6 lots for 64. 1 inch is 4 feet for 65, and 24 by 24. You could also have put 25 by 25. You also could have put 24 point whatever it was, 8, 4, 9, whatever. Yeah, don't really care. They said it needed to be about. The big issue with 66 was that those two numbers, of course, had to be the same because it said it was a square room or house. Yeah. Okay. So one last lookaroo. I'll give you a hint that on 62, I really like those problems. And I tend to put problems I really like on your quizzes and tests. So this is my hint to you that some of you will pick up on. Are we okay with answers? Again, like I told you guys, if you ever don't get enough time, you're always welcome to come grab my workbook and see the answers. I don't do the homework until you do the homework. So it's not like you could come and I don't have the answers to everything filled out, so, you know. But you're always welcome to come grab this and take a look at the answers. Or ask if you need something. Okay. Anything else? What ones would we like to see? Dominic?
60.
60. Anything else? Meadow? The circle ones? Anything else? 64? Okay. I'm gonna go, I'll go for 5 minutes, so we'll see what we get through. Okay? If you don't care about this part, bad choice, but you should then just be quiet. Okay? Okay. 60, we can do this, for 60, I'll get there, don't you worry. Thank you, though. For 60, you have something like this. 40.
I know what people have gotten wrong.
Hold up, I do too. Okay, 45 inches. All three of those are 45 inches. So that means this total side is 135 inches, adding them all up. And the area is not too tough. We know that it's base times height, or 48 times 135. So you get the area of the window as 6,480 square inches. Now, and then, of course, here's where we make the mistakes, because square inches are, of course, different than square feet. It says that the glass is sold by the square foot. So we need to convert inches into square feet. Notice again another unit problem, just like you just had. Okay? When we do square inches, every time I do square inches, like this is my workbook, right? I don't necessarily have to even show it to you, but you can see, here's what I do every time, because I'm just a visual person, and I kind of always need to think about it for a second. I know that square feet, there's 12 inches in a foot, so I always draw this little square. Like every time I have to do a unit conversion, I have to redraw my square, because that's just how I think, okay? But I have that 12 times 12 is 144. Some of you might have noticed that square inches need to be into square feet and divided by 12, which is a nice thought, but it's wrong, right? Because we need to divide by how many square inches are in 1 square foot. Okay, so 1 square foot is 144 square inches, and I'm going to show that again. If this is 1 foot, we know that's the same as 12 inches. So we have that here is 144, and that 1 square foot equals 144 square inches. So to get my square inches into square feet, we are going to do 6,480 divided by 144, which gives you 45 square feet. And if it's 45 square feet priced at $7.60 per square foot, multiply per square foot to get your answer of $342. Okay. Questions? Concerns? Sure? Now's your chance. If you have a question, I guarantee someone else in this room has it. Okay, fine. 61 then. I'm just going to do the first portion. It says that we are trying to find the area of the white. I will. We are trying to find the area of the white space.
Can you do the second one?
Instead of that one?
Yeah.
Okay.
I think
Not drawn to scale. Okay, so that's the second one of the circles. Again, it's saying, suppose we have these circular housing lots, and we're trying, or circular houses, and that's the deck, is the shaded area. And so we're trying to find the area of the white piece. Okay? That means I need to find the whole area of the circle, and I need to subtract out the shaded piece. Okay, I need to subtract out the shaded piece. So here it also tells us that the radius is equal to 24 feet. So I'm just going to go ahead and find the area real quick. The area of the circle is radius squared times pi. I don't know what it is. 24, 596, science, math. 1809.56 square feet. Okay, so there's the area of the whole circle. But we need to find out how much of the circle this little part is. How many degrees are in a circle? 360. So if all the white is 300, how many is that? 60. Right, 60 degrees. So to figure out 60 is what portion of 360, I can divide them. And I get this weird looking number. I don't really know. But I do know on my calculator how to turn anything into a fraction. If I hit math, this says it's going to turn it into a fraction. And so on my calculator screen it says I'm turning that answer, that decimal, into a fraction. And it tells me that it's 1/6. Okay? So that little piece, this is 1/6 of the circle. So if I could find out what 1/6 of this area is and subtract it, I would get my area. Okay, so I'm going to do that by subtracting 1/6 of the area. To figure out what 1/6 of the area is, I'm going to do 1/6 times my area formula, which is 1809. So that means the area of that little shaded piece is 301.6 square feet. This piece, 301.6 square feet. So your total area would just be this 1809 minus the 301. Whoa. So, and I rounded that to 1508 square feet. Okay. So again, to point out, this is not me teaching you. This is me reviewing what you should have already done. So if you're like, well, you went really fast. Yeah, I did. I'm also going to throw out that you're not allowed to have your head down in this class. Yeah, here we go. I'm talking to you. Yeah, there we go. Head up. Yeah, I know. Okay. All right. Get out your papers, please, from Wednesday. to share with your neighbor, and by share, Raul, by share, that means we're just going to do the back problem. If you don't have yours, you can go ahead and look at their paper, get the points, and graph it in your notebook. Okay? Or you could look up there. You have 4 minutes. 4 minutes as a table to do those questions. Okay? So that means you're talking to each other if you need to. You only have 4 minutes. Ready, set, go.
I have no idea what a scale factor is. I never went over that. I did this all. What's a scale factor?
You know what a scale is? It's not a scale.
I know what a scale is, but I don't understand it, and I don't understand it.
Yes. That one. That's how long it took me. 1 hour. That lots of us go, ooh, it has been some time since I've graphed some points. Okay? Yeah, that's okay. If it's been a while since you've graphed some points, check it out. Okay? Points are always graphed with the x coordinate first and then the y coordinate. So if I'm looking at my axes, I can see these are the x coordinates going along here because it tells me x, and these are the y coordinates going up and down. So if I'm plotting the A would be at -1 on x and -2 on y, and so I'm trying to put the point where both of those things are true, right? So here I'm at -1 on x and -2 on y. Okay? So that's point A. Point B is 3 on x, -2 on y. If you've got your points wrong, then fix them. Erasing and redoing. Point C says it's 3 on x, so 1, 2, 3, and 1 on y. And then D is over here to complete the rectangle. It tells you it's a rectangle, right? We're forming a rectangle with those points. So I'm going to make it nice and rectangular. There we go. Very least, we should all have that part done. Okay? And then it wouldn't be too much of a stretch to say that I'm going to write my area up here. The area of A, B, C, D. Right? From A to D is how long? 3. We can count. D to C is 4. So we know the area is 3 times 4, or 12 square units. Now, the next part says we're going to use a scale factor of 2 to make a new rectangle. We've been working on scale in here. It means if my scale factor is going to be 2, I'm doubling each side, right? I'm blowing it up by 2. Now, it doesn't necessarily matter to me right now where you put your rectangle because we haven't talked about it, as long as the scale is right, okay? But point D would be here at -2, 2. That's our new point D, or D prime. Okay, A would be -2, -4. This would be my new A. B would be over here at 6, -4. And C would be up here at 6, 2. Okay, and the important thing here is checking out the scale, right? If originally A to D was 3, What should my new A prime to D prime be? 6 because why? Because we're doubling, because the scale factor is 2. If my scale factor is 2, that means I'm doubling. So A prime D prime is now 6. And then what's this top length here? 8, because 4 times 2 would be 8. Okay? That means our scale factor is 2. So we doubled each side. Okay? And if I wanted to find the area of that new rectangle, it would be 6 times 8, which is 48 square units. So when I'm looking at this area, what was the area multiplied by?
4.
But what was our scale?
2.
Uh-huh. So what's up there? Okay, so here's the question that I want you guys to think about in your groups. I'm going to give you 2 minutes to come up with an answer, and then I'm going to use cards. So Malachi and Major, maybe pay attention to this part. Okay, Cecilia learned it last time. I'm going to use cards and call on you. So as your group talks, come up with something that you're going to say. Have in your head how you know you're going to answer this question, so that if I call on you, you don't go, okay? So here's my question. What is my question? That's a good question. How do I want to write it? Oh yeah, here we go. Why is the scale factor for the sides 2, but for the area, it's times 4? Okay, so, right, we know, again, here's what I'm asking. Got it. The scale factor we said was 2. We doubled each sides. Why then, instead of doubling, right, the area didn't double, it got multiplied by 4. My question is why? Why did that happen? As a table, 2 minutes to come up with an answer, and then we're using cards. Go. Well, what?
Dude, you said it out loud.
Have a little conference. Get your answer. Hey, have a little conference as a table. Come up with your answer again. Or I'll... Listen. Shh, shh. Go ahead.
Multiplying by 2.
How many times do we multiply by 2? Right, so each side got multiplied by 2. Here's what table 3 is saying. Each side got multiplied by 2. Since I multiplied sides by 2 twice, that's the same as 4. I think that could be beefed up a little bit,
yes,
though. Hey, Sam, pick your head up. Stevie. Okay, since I doubled the side lengths, I double the scale. What if I tripled the side lengths? What do you mean? Chris, add. Okay, let's test out what Chris just said. We're going to test this. He said if we tripled the sides, we would do 3. If the scale factor was 3, We'd multiply the area by 3 cubed.
It's sort of like.
Okay, hold on. Okay, look. This is big. Let's see if Chris is right. Let's triple the sides. If I triple the sides, what are my new dimensions of the original box?
108.
No.
9 and 12.
9 and 12.
And it's a lot.
108 square units. 12 times what is 108? This should be easy because we just did it. So look. Let's check it out. If the side scale was 2, what was our area scale?
4.
If the side scale is 3, what's our area scale?
9.
9.
Oh, it's pretty much like your square.
Why is it squared?
Oh, because it's a
What kind of measurement is area?
squares.
A square measurement. Okay, so look, if, hey, this is big. When we're talking about area, it's the area is going to be multiplied by the scale squared, because area is a square measurement. Okay, so also we just did with this problem in our warm-up. Hands down. I'm sorry, when we talked about our homework, right? We just did square feet to inches, to square inches. Okay, it's a square measurement. All right. So we need to put some stuff in our notebooks because last time we left off at a weird spot. So get out your notebooks, please. And without talking, that means your voices are off. The next page. Hey! Shh! Without talking means you're not talking. Shh. We are talking again about similarity. We left off in kind of a weird spot with a not very good definition of similarity. Last time, your definition of similarity was that it has the same angles but different sizes. Okay, we're going to add to that. Okay, our new definition of similarity and our actual working definition . I'm really close to starting to kick people out for interrupting me. Okay, not of similarity, of similar. Our definition of similar shapes. Are when corresponding sides are proportional. That was Meadows' word of the day on Wednesday. Corresponding sides are proportional and corresponding angles are equal. Okay, in order to be similar, the corresponding sides must be proportional. We'll talk a little bit about what that means through an example. If I have this triangle these two triangles. It doesn't necessarily mean that they're facing the same way, right? They could be even reflections of each other, right? But still, it means that the corresponding angles, the angles in the same spot, are all the same. So here, if we look at the two legs of the right triangle, there's a 90-degree angle, and it's in the same spot over here. Okay, those are corresponding angles. Same thing when we're talking about sides, the corresponding sides, right, are the sides that are in the same place. So like the hypotenuse and the hypotenuse, short leg and short leg. Okay? And if we look at this, there's two different ways to talk about the proportionality of these. Okay? Give me one thing that we notice between on these triangles. One way to talk about the proportions. Mickey?
The small one's measurements are triple.
Going from to the next triangle.
Yeah.
Okay, so from the small triangle to the larger triangle, 1 times 3 is 3, 2 times 3 is 6. So they're proportional across between the two. Okay, that's definitely one way they're proportional. What's the other way that they're both the same? Someone I haven't heard from. Duke. Yeah, they both have right angles, but what about their side lengths? So what do you notice about the side lengths on the small triangle? Taylor?
That they're like which part?
Like what's the relationship between 1 and 2?
Oh, that they are like as low as they can get. Like your the ratio between they one and small.
Okay, go expand on that, Maximus.
They're double one another.
Yeah, they're double one another. So there's two different proportions we're talking about, right? There's what Mickey said, that from one triangle to the next, our scale factor, or the dilation, hey, that's a vocab word we're talking about. Dilation is one side getting bigger or smaller, okay? There's a dilation between them, and the short side is being multiplied by 3, but within the two triangles, right, the long side is twice the short leg, right? 1 times 2 is 2, and then it works over here as well because 3 times 2 is 6. Okay, so there's two different proportions that we're talking about. And here, the fact is that 1 over 2 is the same as 3 over 6.
Good afternoon, students. This is Ms.Stolte with a quick announcement. Just a reminder to our students that for today's flex schedule, academic classes will be in department meetings this afternoon.
I don't really care because I already know.
Classes will be available from students in the tutorial this afternoon.
Pick up the phone and put it down.
Oh, you can't. Oh, good, good. Ooh, now I never am going to hear another announcement. This is good. Thanks, Finn. Okay. Nothing. Because it's not important. Flex day, Ms. Horatio will be here for flex. I won't. There you go. Okay. Because we communicate with you. And so if you're not listening to us, why are you going to listen to him? I don't know. Okay. This is a proportion, by the way. Right? Comparing two fractions. That's what a proportion is. Here, non-similar example. Let's use rectangles. If I have a 2 by 3 rectangle and a 3 by 4 rectangle, these are not similar. These are not similar. Okay? You could say, you might say, by trying to argue, oh, but Ms.Stolte, they are, because the corresponding angles, you just added 1 to each side. You added 1 to each side. But that's not what we're talking about. Similarity is a multiplicative thing. Okay, when we're talking about scale, it's that you have to have the same multiplier. It's cool, great that you added 1 to both sides, but that means they're not similar. I can also tell that because if I compare the two in a ratio, the ratio of these two sides, 2 to 3, is not the same as the ratio of the other rectangle sides, 3 to 4. Right? Because 2 to 3, I could always check on my calculator. 2 divided by 3 is that, and 3 divided by 4 is this. Those are not the same. Right? They're not the same. Not the same proportion, so those are not similar rectangles. Okay, last example, then I'm done talking to you. Easy, medium, or hard?
Hard.
Okay, we heard easy and hard, so that means medium. Here you go. The two triangles are similar. I would like you to please find the missing side length. This is triangle A. This is triangle B. Okay, so you'll have about a minute in your tables. If you're not sure how to do it, talk to the person next to you. Be like, do you know what? For the shop? Oh, you don't know when you're posted? Well, he's not allowed to pass on. Because technically you're supposed to be able to have that time to be able to go. But he's not going to do that all the time. So if he said 2 or 6, he can't do that. I mean, he can't like push to it. So if there's a, if you need to go talk to the teacher to stay here, certainly do so. Other than I can always talk to you for a bit. Then I'll leave it out. No, you're allowed to. Huh? Hold up. Yeah. Good call. All right, listen, please. Who feels good about this? Who can tell me what's what? That's it. Come on. Badger.
Is it 10.5?
Oh, I don't know. Tell me what you did.
I did 4 times 1.5 equals 6.
Wait, hey, how did you get 1.5?
I got that in my head, Mariel, so I thought that would work.
Okay, let's not get. You're right. How could I get 1.5 if I didn't know how to get things in my head?
6 divided by 4.
KG. Hold on. How do I get this number? How do I get 1.5? Go ahead, Mariah. Yeah, divide. 6 divided by 4. 6 divided by 4 is 1.5, which means that 4 times 1.5 is 6, which it is. So if I want to know my other side, all I have to do is 7 times 1.5, and I get my answer of x is equal to 10.5. Okay? So, you guys just got a sheet of paper. If you are red, at a red card, hearts or diamonds, you are doing the left-hand column.
Can we do all of them?
If you are a spade or club, a black card, you are doing the right-hand column. Sure.
Wait, is this today?
Right. Yeah. It's classwork. That's pretty good. Not bad. Shh, no, Cecilia, no. Gotta go to the shop. Please make sure you know your homework for today is 68 through 75.
68 to 75?
I wonder if it, did it build better?
21 is Ms.Stolte.